Hello, everyone. Welcome to Professor Messer's Network Plus Study Group. This is our live study group. We do once a week, or once a month. I wish I could do one once a week. Wouldn't that be great? You always send me emails that say, can we do another one of these tomorrow? Except it takes a little bit of time to put these together, but I'm happy to bring it to you once a month. You send me all of your questions throughout the month, and hopefully I'm able to answer some of them. What we've been doing in our live study groups for the first hour is I ask you questions, and I see how well you do. So I have a number of questions set up for you today, all about topics from the Network Plus certification. I've taken your questions about the Network Plus, and I've put them into these multiple choice questions. We'll talk about that in just a moment. There's quite a bit that has been going on at the Messer Studios over the last month or two, and even more happening. But before we get into some of those things, I do want to say thank you for your support for this, what we do on the study group and what we do throughout the month. I really would not be able to do it without your support. And it's a lot of the people that do things like purchase our offline video course for Network Plus. So you can, of course, watch every video that I have, every minute of every video, absolutely free for Network Plus out on ProfessorMesser.com, or you can even go to freenetworkplusplus.com if you want a really quick way to get there. But some people like to have these offline, like to be able to take them when they're away from the internet, when they're on a plane. They want to be able to watch them on their television through their Xbox One. You can do that with this DVD-ROM set. And if you'd like to find out more about it, you can find it at ProfessorMesser.com/download-Network Plus. Could I make this even harder for you? There's plenty of links on my website to also find out about that. And of course, keep track of what we do all the time. You can follow me on Twitter, where you would have gotten a message about this study group 5 minutes before it started. And of course, you can see all the new videos that are going out on YouTube, working through the newest Security Plus course right now and adding all those new videos. We've already finished production for all of that. There is also a lot happening live right now. I'm watching what you're doing. You're going to also be answering questions. If you go to any page on ProfessorMesser.com, you'll see a chat at the bottom for the live Network Plus study group. If you're watching this on the YouTube site, you'll notice there's no way to put in any type of comments there. You would have to go to ProfessorMesser.com. And if you go to ProfessorMesser.com/live, you will be able to see the video and the chat at the same time. How convenient is that? Now, I'm going to be asking questions of you today, so please pop open a new window or download the app called Socrative. This Socrative app is one that you can get on Google Play, the App Store from Apple. You can go to the Windows Store from Microsoft, and it will ask you for a room name. You want the student version of the application, or you want to log in as a student, and then you want to put in the room name of Professor Messer, all one word. Professor Messer, all one word. It rhymes, but yet it's spelled differently. Oh, the intricacies of the English language. And if I could only, now, although you'll notice if you do mess up the name when you're typing it into a domain name to get to my site, it magically gets there. Try to cover all the bases. So what you will see when you go to that page is something that looks like this. In fact, I could probably even make that a little bit bigger if I get it on here. You'll get this either in your app or you'll get it on your screen. It will say, and this is the first question I'm going to ask of you, which is how long have you been studying for your Network Plus certification? And your options are less than 3 months, 3 to 6 months, 6 to 9 months, 9 months to a year, over a year, or I've already got my Network Plus certification. Maybe you're watching this for some continuing education credits, which is kind of nice as well. Very, very nice to have that there. So you should see that option now to be able to do that. Here's the link and the room name to be able to see that. I'm going to pop over and see that, yes, there are people that have seen it and are indeed answering the question with those pieces. So there is quite a bit there that people are answering. So I've got a screen that I'm able to see on my side that shows me interactively what you're voting on. So of the people that have gotten in there and answered already, we have 53% that have less than 3 months amount of time on this Network Plus path. 3 to 6 months, nobody. 6 to 9, 5%. Then my people here, over a year, 10%. 29% of you already have your Network Plus, and you're just here for the free refreshments, which is fine. I have no problem with that. So you got things you can do with that. If you're just getting into the Network Plus certification, there is this version. If you have study materials you're looking for, if you have a book, they should all be for the latest version of the Network Plus certification, which is called N10005. So if you have a book that has any other number on it, like N10004 or 003, those are old versions. You can get rid of those books. You need to get a new study material for this because the Network Plus certification is updated about every 3 years. Now, you'll notice that it was released December the 1st, 2011, and if you count 3 years, we're at about almost coming up on 3 years. So I'm thinking by the end of the year, we may get an announcement about a new Network Plus certification, but even then, CompTIA tends to give you a number of months. In the past, they've given you 6 months of some time so that once they announce the new version and make it available, which could be N10006, let's say, if they stay true to form, and they'll give you another 6 months where you can take both exams. So don't feel that you're going to come up to December or the beginning of next year and you'll be rushed because you've got plenty of time to take your exam. Do not worry about that piece. This latest version of the Network Plus exam, when it came out in 2011, added a lot more information about virtual networking, a lot more about the OSI model. There was more security in this particular exam. So it's very well up to date with the latest technologies and things happening in security. And that's one of those that I really am able to keep track of and stay on top of. There is one of just something to keep in track of is N10005 is the important thing. If you have a book that has another number on it, you may want to consider getting an updated version. Even though there wasn't much of a difference between the 004 and 005, there was new material. And I would hate for you to go take that exam and then you do not have a way to understand what they're trying to tell you. One of those things about it. One of the things we also do on the Professor Messer website is we keep track, or at least we are able to provide you with other things that can help you study. One of these is my study guide. The Network Plus study guide that I offer is a PDF. So once you've read your book, you've looked through all the videos, and you need something to help you really get the specifics of the Network Plus exam, I've taken all of my notes and all the materials from all of my videos, and I put them into this study guide, an 11-page PDF document that you can purchase and download immediately and have available. This is a bit of a cheat sheet, if you will, except you're not really cheating, you're really studying, but it's a way that you can also help contribute back to the Professor Messer website and keep things up and running. It's $10 and it covers every possible thing that is listed in those CompTIA Network Plus exam objectives, the subnetting, the protocols, the connector types, all of those different port numbers that you have to remember. There are subnetting tables on that. There's a lot that goes into this study guide. If you'd like to see more about the study guide, see if it's for you, you can go to professormesser.com/netsg. And I want to thank everybody who has purchased the study guide in the past. Every bit of this goes back to keeping the website up and running and keeping things going on the website. So I can't thank you enough. It really does go quite a long way. Well, let's start answering some questions about Network Plus. Let's see if I can get over to the right screen here. Let's go through some of these questions and start trying to find out some of the things that, see if you know the answer to some of these things. So in the chat room, you're already asking, how do I answer some of these questions? Well, this is the way you might do it, is through this particular view of it. So the question that I have for you next, as I push this next button, is which one of these things would be the best thing to check if you have a problem at OSI Layer 3. If you go to Socrative.com and go to room name Professor Messer, you will get these prompts available. So if you have a problem at OSI Layer 3, would you check file rights and permissions? Would you check the subnet mask configuration? Would you look at your firewall port number security policies? Would you deal with near-in crosstalk? Or would you go to the switches MAC address table? Not switch the MAC address table, but your network switch has a MAC address table inside of it. Maybe that's what you should look at for an OSI Layer 3. You can lock in your answer. You notice that it gives you an option to choose multiple answers on the Socrative, but I'm only looking for one unless you happen to see in the question itself that I'm looking for more than that. So go out to Socrative.com and be able to answer this question. And there's the room number again. And I can see a few people are already there. One of the things about this stream, by the way, is you're seeing it about 30 to 45 seconds after it goes out. So it'll begin on my side adding these things up. You'll start to see those things happening on the screen. Those question and the answers again: file rights and permissions, subnet mask configuration, firewall port number, security policies, near end crosstalk, or MAC address table. So now I'll give you a little glimpse there what people were answering. I think we've got a few people that have answered in here so far. I need to adjust myself with what's here as well. One of the things about the Network Plus exam is they really go deep into the OSI model. They want you to really, really, really understand the entire OSI model and all of the things associated with it, and be able to apply the different layers of the OSI model back to the real world. So what I did with this particular question is I gave you a series of things that are all in very different OSI models. So if you're going through this question, one of the things you can do is start looking at the possible answers, like file rights and permissions, and think to yourself, what OSI model does that go into? What layer of the model does it go into? Subnet mask configuration, what layer is that fitting into in the OSI model? And do that with each one of these things. Each one of them, by the way, is in a different layer of the OSI model. I specifically put a very different one in every one of these. So let's see what responses we have and the answers. I think we got a good group in here. I don't think I fooled very many people with that one. It is not file rights and permissions, although 5% of you did choose that particular option. It is not the subnet mask configuration. Nope, it's not, or it is the subnet mask configuration, 83%. It's not the firewall port number, 13%. Nobody chose near and crosstalk. Nobody chose the switch's MAC address table. So we are talking about the OSI model. And it's one of these things that it's so, it's a model. It's not a real thing. It's not physical. It's something that is a concept. And so it becomes a little bit of a challenge when you're first trying to learn the OSI model of how all of these things fit into this. And in my videos, I do that sometimes and trying to get that, give you different ways to look at the same type of information. So if we look through this particular question, file rights and permissions, anything dealing with the operating system and how it operates could be at layers 5, 6, and 7. Generally, that's an application layer type perspective. You could almost put it into layer 6, but I tend to think of file rights and permissions as layer 7. I tend to also group together 5, 6, and 7 sometimes, although that's not entirely the way it is considered. But from a networking perspective, which is where I come from, that's one of the things I work with. Subnet mask configuration, definitely an OSI layer 3. Anything dealing with IP addresses, with routes, with routers is always layer 3. If you're talking to a network professional and they're saying, I need to check the layer 3 configuration on that router, they're talking about your IP address, your subnet mask, your default route, anything that's relating to that layer 3 piece of information. Firewall port number security policies. Port numbers on a firewall, at least in the traditional port number sense, are at OSI layer 4. So that's not a layer 3. That's absolutely a little bit higher. Just above the IP address is exactly what port number you're going to in that IP address. So that wasn't the correct answer. Near and crosstalk, you can think of a layer 1 type problem. We are not able to get signal from one side of the network to the other. And that signal on the cable is really what OSI layer 1 is all about. And lastly, the OSI layer for E is the switch is MAC address table, OSI layer 2. Anything dealing with a MAC address or a physical address of a device, and generally we think of physical addresses as MAC addresses, but if you're on a wide area network, they may not have MAC addresses. That's not Ethernet. It may be a T1, and you have a DCE and a DTE side. Well, those are the layer 2 addresses as well on your T1. So on a switch, we're dealing with Ethernet, generally speaking. Your OSI layer 2 is going to be that MAC address or physical address of what is going on the network. So there's a good example of, as we step through these types of problems and dealing with the OSI model, that we're really thinking about how these things work. In fact, you can go to this. I know it's kind of difficult to see on this screen, but layer 1, the physical side, is those electrical signals. Layer 2, Ethernet. 3, OSI layer 3, the IP encapsulation. TCP is layer 4. You have this link presentation to the transport is really what's happening at layer 5. There might be encryption at layer 6, and layer 7 is your app. And there is a video that I have in my Network Plus that goes through the OSI layer in the real world. So it gives you a way to consider how the OSI layer works from one side to the other. All right, chat room, that was pretty good. Thanks for following along with some of the things that we're doing there. I am checking the chat room occasionally to see if there are any questions about those pieces. So that's something that we can always go to. But I have more questions. There's plenty more questions. Let's go to the second question. So I'm going to click this so you can see it in your Socrative, which you will see before I even say it, which is, which of these protocols would you use to gather router statistics from your management workstation? Go to Socrative.com to the Professor Messer room, and you'll be able to answer one of these, which is SNMP, IMAP, NTP, DHCP, or SMTP. There's a lot of letters in this. So that's one of those times where you want to really get into the details of understanding two steps. And I often do this with my questions. It's a two-step question. First, you have to understand, I'm asking, what protocols would you use to gather router statistics from your management workstation? So already you have to know what I'm talking about when I say that, because I'm giving you a clue as to what it is. And once you have that clue, you then have to put it into the abbreviation for that particular protocol, which is SNMP, IMAP, NTP, DHCP, or SMTP. And you have to figure out in your list, okay, this statistics, router, management, what is that? And then figure out the answer based on those pieces. This is one of those where you do have to know these abbreviations. You do have to understand these protocols. There's a big section of the Network Plus certification that goes through different kinds of protocols. It actually gives you an enormous list of protocols in the exam objectives. What I did was take that list and I separated them out into very common functions. So file transfers, I give you all the protocols for file transfers. Things like router statistics from your management workstation, I give you that family of protocols. I give you another family for encryption. So you're using different ways to look at the data and deal with it. So if we look to see who might have answered so far, I'm going to pop this open. I think we've had plenty of time to see what our options are with this. And we had things from all over the place for this particular answer. 83% of you said SNMP, the Simple Network Management Protocol. You would be absolutely correct. That is clearly the one that people chose. 84% of you. 9% said IMAP, not quite right. That is an email protocol, so that's not going to gather statistics from a router. NTP is the network time protocol, although it looks like it would be network management or network processing or something. Maybe that would work, but unfortunately not correct. DHCP is the automated way of gathering or getting an IP address once you connect to the network with your dynamic host configuration protocol, and E is SMTP, another mail transfer protocol, and none of you were fooled with the mail transfer protocol piece. We don't really use SNMP, the Simple Network Management Protocol, in our day-to-day because generally we're not monitoring routers inside of our homes from our laptop. But if you're working in an environment that has routers and switches and firewalls, and you need a way to keep track of the health of those devices, and SNMP is a perfect way to do that. That's why we built this protocol where we are sending a query to a device like this router and saying, could you tell me how many bytes have come into a particular interface on that router since the last time I checked or since you were booted up? There's different ways to ask for these things and extrapolate them. And the router is going to reply back with a number. So in this case, the router replied with 210506. Just gave a simple unprocessed, here's the answer. And what I'll probably do is wait 60 seconds and I'll ask again, or I'll wait 5 minutes and ask again, and I'll compare the two numbers and be able to get a delta between those time frames and then put that on a chart so I can see exactly the different levels and what I'm working with, the different types of things. There are different types of SNMP, different versions. Back when we introduced SNMP, Well, I guess it was version 1 then, but at the time we didn't know it was version 1. We just knew it was SNMP. SNMP is the structured tables. It's in the clear. We're asking for information that's not encrypted. We're receiving information that's not encrypted. And it was a very common way, still a very common way to query these devices. But of course, in a very secure world, probably not the best way to go about gathering that information. Version 2 helped a little bit with this, because usually when you're querying a router, the router might have 10 interfaces on it. And with version 1, we had to ask, please tell me how many bytes came into interface 1, and you get an answer. Then you have to ask how many bytes came into interface 2, and you get an answer. And you have to do this 10 times with 10 responses. Version 2 created a bulk process where I could say, please tell me for interfaces 1 through 10 what the answers, what the interface in bytes are, and it sends one packet back that has all 10 of those statistics in it. Much more efficient, but still in the clear. With version 3, this is generally the latest standard that people will use, and anybody who's doing real SNMP in their environment are looking for devices that support this. Version 3 has encryption, it has authentication mechanisms. Nobody can sit in the middle of this conversation and be able to find your password, your SNMP code that you're using to gather these details. Very, very important to do this. And in the chat room, Benny's asking, well, can I just use SSH to do this? You cannot, because SSH is a completely different protocol. SNMP is a completely different standard. It is using its own protocol to be able to transfer this information. So SNMP is a protocol just as SSH is a protocol, so I couldn't do both of those. SNMP is expecting a certain kind of request, and it's going to provide a certain kind of response. That's part of the standard. So version 3 does allow you that encryption part. That's the important part. So that's what people were saying, is that I'm using SSH to have a very protected, secure connection to my router or my switch or my firewall. Why am I not doing this with my management statistics? And so we are. One of the important things about SNMP is not only can you retrieve statistics, you can technically make changes to the configuration of a device through SNMP. So that becomes very, very important whenever you're thinking about security of these devices. And if you're sending information in the clear, potentially an attacker could find the code that's necessary to gain you that access and be able to get into that device and make changes. So version 1, you're not protected from that. Version 2, you're not protected from that. You really want to be running SNMP version 3 today to do any of those things. Well, that takes us through the SNMP. We're doing pretty well so far. So let's give you another question. Let's stick with this idea of ports and protocols. And the question is, which port would you open in a firewall to be able to allow the encrypted terminal sessions to operate? So we haven't really talked port numbers yet. And that's for a very good reason, because now I'm asking you about port numbers. So what port would you open in a firewall to enable encrypted terminal sessions? Would it be TCP/20 and TCP/21? Would it be TCP/443? Would it be TCP/143? Would it be TCP/22? Would it be TCP/23? A lot of different options available. And of course, you can go out to, if you're not in there yet, you can go out to Socrative.com, click the student login button, put your name in there, go to room name Professor Messer. And I think that's when it asks you for your name once you get inside of there. So you've got a few options here, especially when you're thinking about firewalls. You may be asked on the Network Plus exam, you need to configure a firewall. Here's what you're doing. There's a big section of the exam objectives that expects you to know how to configure firewall settings. So there's an entire video on configuring firewall policies, and those policies will expect you to know things like TCP port numbers. Traditional firewalls have always used these TCP port numbers to do this. Today, firewalls are much more advanced, where it's looking for certain application types. You don't even have to put port numbers in there if you don't want to anymore. It knows if something's Twitter. The firewall knows if something is Facebook. It knows if you're using Google Mail, and it's able to discern all of those things, even if they're all using the same port number. But you still have cases, especially for inbound traffic, where you may want to configure certain port numbers. So it's important to keep in mind what those might be. So you've got the options there to be able to look at those. And I love when I get a good mix of things. And here's a good example of a good mix of things. So there's a few things to look at for this particular question. The question again, what port would you open in a firewall to enable encrypted terminal sessions. And that's the key. Remember, it's always 2 steps. I try to put 2 steps in a lot of my questions anyway. So in 2 steps, I want to first understand what encrypted terminal sessions are, and then I need to know what protocol that uses, and then I need to step through and understand which one of these things I'm going to be looking at. So first, I need to understand an encrypted terminal session. So it's not just encrypted. Don't stop reading when you see the word encrypted. Go the next step and read terminal sessions, because an encrypted web session over port 443, that's a web browser. That's not a terminal session. A terminal session is going to be something like Telnet, which is not encrypted, or SSH, the secure shell, which is encrypted. So now that we've gotten our minds SSH, we also have to know what the port number is for SSH. So if we look at some of the port numbers available, FTP is TCP ports 20 and 21. We're not talking about file transfers. We're talking about terminal sessions. And that secure shell terminal session is TCP port 22. Telnet, which is a non-encrypted terminal session, would be 23. SMTP mail is 25. So TCP port 22 is our secure shell. And if we look at this, 42%, 43% of you did say TCP port 22. A lot of you said TCP port 443. I threw that in because I knew people think encryption and they think web browser. And in fact, I put it, notice, a little higher than TCP port 22. I put a lot of thought into these questions and how people are going to read them. And their first thing they'll see, 443, it's encryption, got it. And that's, you need to read the entire question, understand exactly what's being asked of you. It's not really a trick question. It really just expects that you go through the entire question and know exactly what it's asking for you. So very important to consider that. And TCP port 23 obviously got the terminal session part right, but that is a non-encrypted and in the clear communication over TCP. So that's one of the cases where you do have to know a lot of ports. There's a lot of port memorization on the exam, not just the ones we looked at there. Here's more ports you have to know. You have to know DNS. You have to know HTTP. You have to know POP3. You have to know IMAP4 and HTTPS, of course, for the encrypted web sessions. There's even UDP. I think one UDP port you have to know, which is DNS. There's 2 on the exam. There's also the BootP and the DHCP are over this, and you've got TFTP on this exam that you also have to know for the UDP. So you not only have to break down NTP, a TFTP, BootP, DNS on the UDP side and SNMP, but you also have to know all those TCP ports as well. So it's one of those things that sometimes if you don't work with these protocols over and over and over again, it becomes a little bit more of a challenge because you're not accustomed to doing this. It becomes more rote memorization. But this is one of the cases, though, that the Network Plus exam expects that you're going to be using these things. And trust me, if you get into a networking role, you're going to be using these port numbers all the time. They're just going to start to become second nature to you. So don't worry so much about those ports and what's associated with them. What you really should think about is memorizing them now and knowing you're going to use them later. And then if you have a chance to configure a firewall or set up a personal firewall on your computer, or you'd like to try to see if these port numbers really work, gather some packets with Wireshark, set the configurations in your firewall, see if you can block HTTPS or HTTP or DNS in your firewall by using these particular port numbers to be able to do that. And a good example, yes, when you're going to FileZilla to upload data to the server, you're using an encrypted file type. We don't have that encrypted file type in the Network Plus configurations. Those encrypted file types also have a ride on top of SSH to be able to do that. So if you're using a file transfer that's using port 22, it's probably using SSH to do that. So there's quite a bit to go through with those pieces. Let's look at another question then. Let's go through those pieces that is in here. And the next question I have for you is, which of these standards uses DSSS? And you've got some options here for these different standards to use DSSS. Again, you have to know what DSSS is and what I'm talking about to be able to do this. The first option, 802.11b wireless. Option B is DNS. Option C is API-PA. Option D is 802.3 Ethernet, and option E, VTP. Each one of those things are on the Network Plus exam. Again, if you'd like to answer this question, you could go to Socrative.com and go to room name Professor Messer to say which of these standards uses DSSS. And for those of you asking questions, that last one, I showed you every port from the Network Plus, but there are more ports on the Security Plus exam. There's a little different, and there are different ports on the A Plus exam as well. You'll need to check the exam objectives for your exam. I expect that will even change when the next version of Network Plus changes, because it changed when it came to this one as well. So there's different ports. I don't know if there's any more or less on any of those exams. They don't ask a lot of you. Network Plus probably has the most of all three of those. Okay, take a sip. Let's keep the voice going. So, which one of these standards does use DSSS? It's a quandary. It's a query. So, again, a two-step process. We have to know what DSS happens to be, and then we have to know where we would use something like that. This becomes a bit more of a challenge, especially if you're working on the security side and the networking side. You're going to run into these types of nomenclatures to be able to do this. So let's see how you answer with this one. This one's a little bit more of a challenge because DSSS is sort of an odd name to be able to work with those things. Well, if I told you that DSSS stands for Direct Sequence Spread Spectrum, that might give you a hint. And in fact, the hint there probably isn't one that's needed for this group, because if I look at how the answers are going, I can see that 69% of you said 802.11b wireless. Absolutely. Now, you notice I didn't make it much harder than that. I could have said 802.11b, 802.11g, 802.11n. Could have given you different 802.11. So the one thing to keep in mind here, the correct answer indeed is A, 802.11b. DSSS, being a direct sequence spread spectrum, is not used in DNS. It's not used as API-PA, which is the automatic IP addressing mechanism. The 802.3 Ethernet does not use that as a modulation type across the wire. There's many different modulation types that are used in Ethernet. You'd have to then ask somebody, are you talking about 100 megabit? Are you talking about gigabit? Are you talking about over fiber? Are you talking about over copper? So it doesn't even apply here because we're talking about spread spectrum going across the air. And VTP is not being used in this particular case for this piece of it. The one thing that is important to keep in mind is wireless. We are talking about spread spectrum, and there are other types of modulations that are used to be able to communicate across wireless networks. If you go back to the Wikipedia chart, which is also in my slides, thank you, Leibeskind, who put this on Wikipedia. This really summarizes it quite nicely, and very nice that they added 802.11 using DSSS has a channel width of 22 megahertz, and here's the different channels you could possibly use in 802.11b. You'll notice that you've got different types. So when we're talking about 802.11g, 802.11n, we're talking about completely different ways of communicating or modulating that with the orthogonal frequency division multiplexing. So you've got now a completely different method of sending this data across over the air and having it received on the other side. That is what those modulation types are used for. It's the under the hood method of how do you get the data from one side to the other, and that's how you do it, is using these different methods of modulating that data across those radio frequencies. This is one of the most important things to remember for your exam, but in practical use, you don't think much about the modulation of how it gets from one side to the other. But if you're someone who is working a lot in these environments, you may be asked about how does it work underneath? What types of things are going to be important for us to be able to use? And it might even affect the type of antenna that you plan on using to have your network running as well. All right, we're going pretty well so far. Let's go to another question I have, which is, after receiving, let me move this on here. After receiving an IP address via DHCP, when does a device attempt to renew the address? Go to Socrative.com to the Professor Messer room. The options available to you are at 50% of the lease time, 24 hours after the lease, after you get that initial lease, at the end of the lease time, every hour, or the address must expire before a renewal is attempted. So you've got a few options there to go through. There's quite a number of things with DHCP you have to know. You have to know the process of how DHCP works. You have to know the renewal of DHCP. You have to know about leases. You have to know about reservations. There's quite a number of videos on the Network Plus exam about DHCP. So there's some interesting things to go with there. So you do have to know, once you've turned on your machine for the first time, you've received an IP address, at what point does that IP address get renewed, or an attempt to renew the address is made by your workstation? Is it 50%, 24 hours after you get the lease, at the end of the lease time, every hour, or you have to expire the lease and then request it again? How does that work? How in the world do you make all of those things fit together? Go to Socrative.com, to the Professor Messer room, and you will be able to answer that. I do love these questions whenever I'm asking for since we're waiting for people to vote, I will say, got a question in the chat room about the microphone. The microphone is a Heil PR40. It's one you can probably get at a lot of places. I think I got mine from bswusa.com. You can go to heilsound.com, and you could not ask for a better microphone for the money. Been using this one for years and years and years and years. It is just a fantastic piece of technology. I also have a amateur radio license, and Heil Sound makes a number of amateur radio microphones as well. Okay, back to our question, which is lease time information, and we're all over the place with this one for DHCP lease times. The renewal, do we get a renewal at 50% of the lease time? Do we get a renewal? Nobody said 24 hours after it was leased. 33% of you said at the end of the lease time. 2% said every hour, and 22% said the address must expire before a renewal is attempted. So we got quite a few there of options available. Well, there's two important timers you need to know about for DHCP for your Network Plus exam. The first timer is the T1 timer. This is once you get a lease, you get an IP address, it is given a lease time. The lease time for the address is something that is configured on the DHCP server, generally by your DHCP server administrator. And by default, your DHCP client on your computer will wait until 50% of that lease time is up before it attempts to renew. So to spoil the surprise there right off the bat, if you were answered A at 50% of the lease time, you would be absolutely correct. That is the correct response for this. There's another timer that's used, the T2, which means that you're going back to that original DHCP server to get the renewal, to check in at 50% of the time and say, hey, just to let you know, I'm still here. I know we're only 50% through this, but I'm just letting you know I'm going to renew. And that original DHCP server says, well, great, reset the lease time. Let's start over again. But what if that DHCP server goes down? Then you're going to try to rebind this with any DHCP server you happen to have at 87.5% of the lease time. Can we make this more difficult to calculate? So at 7/8 of the time, we've waited. Well, we tried at 50%. He's not there. What am I going to do? Well, I now just need to find anybody. If you really want to see what this looks like, it's like this. So we have this DHCP lease time. Let's say the lease time is 8 days. The renewal timer then is going to be 4 days to check in to get a renewal, assuming that's there. And the rebinding timer, that T2, is 7 days. See how I did it 8 days? This makes it easy for me to calculate. So the first time we checked in at 50%, we got a renewal. Yes. And we've got blah, blah, blah. Let's say that at 50% now, we've gone another 4 days. The DHCP server's not there anymore. It's missing. Where did it go? I don't know, but it's not there. What are we going to do? Well, we're going to wait, and we're going to keep trying to connect to that. But eventually, at 7/8, we're going to hit a mark and say, forget it. I'm going to have to get something from somewhere. I'm going to try finding another DHCP server. And we do, and we rebind with that server, and we get another 8 days worth. So that's the process of timers with the DHCP. Not exactly a straightforward method, given that we're dealing with 50% and 7/8, and working with those pieces. There's quite a lot to deal with when you're working with all of those and trying to figure out the timing piece. But fortunately, there's only 2 timers you have to keep track of. So that works just the same. The chat room, some people are saying, is it different if you're on a wired network versus a wireless network? It is not. The DHCP server is the same. You're getting the same lease information. It is the same process that your client is working through on your machine. There's absolutely the same thing happening in those cases. So it's one of those that doesn't matter. You could be on barbed wire. The DHCP process is going to work exactly the same from a timer perspective. Well, I'd like to take this moment to talk about a fantastic front end that you can use to help with your Network Plus certification called Freestyle. This is from our friends at GTS Learning. They have put together a set of labs that you could step through that are online. They're always available. They are fully working Windows systems with Active Directory servers. There's Wireshark running on systems. You've got fully blown Windows. This is not an emulation of a Windows environment. This is a virtual machine running a full-blown Windows environment on this particular configuration. And it is all available for you to use for 12 months. You could sign up and try it, and there's absolutely free. You can go, I'm going to tell you in a second how you can go and try this for an hour for absolutely free to see if it's for you. And this becomes an important consideration. People are always sending me questions before the study group saying, how do I go through these performance-based questions? Because they might be asking me to do something at a command line. They might be asking me to configure router settings. They might be asking me to configure firewall settings. It's all part of the Network Plus exam objectives. Well, fortunately, the folks at GTS Learning, this is a live view of the Freestyle Labs. You can go into a particular section, say the TCP and port scanning section, and there are machines off to the side that I can power on. In fact, I'm going to use HTML5 in my machine here so that I don't have to load any extra software to be able to do this. I can simply go to each one of these devices, to this server. I can go to this client, this gateway, this router, and this LAMP machine to be able to step through all of the requirements for this particular task, this particular lab. So the first one's on TCP handshake. We connect to the server manager. We add some features for Telnet server. It takes you through step by step. You can see very clearly the things that you're supposed to do. When these devices start up, you'll be able to connect to them. You can almost see on my screen, there's a little orange amber light next to them. The ones that are started up and working are green right now. So all I have to do is wait for all of these machines to boot up. So I don't have to have 5 machines in my lab and I have to go to each one of those and power them on. I simply go into my browser and click a button, and somewhere in the world, in the cloud, there is a machine that is booting up so that I may use it for this particular lab. This also means I don't have to have Windows licenses. I don't have to have a separate machine. I don't have to have a memory upgrade. I don't have to keep track of a build. I don't have to break a Windows system and then somehow try to get it working again. I can simply go to these devices, click on the server, and I'm up and running. There's no lag here. It's like I'm sitting right in front of the device. Go to the control panel. Let's view the network status and tasks. I can go to the adapter settings page. I can view the adapter settings. It's as if I've got Windows running right in front of me, because really I do. It just happens to be somewhere else. All of this is built into the browser. All of the labs are here for all of the different Network Plus hands-on requirements. If you'd like to learn more about this, you can go out to professormesser.com/netlabs, and I'm working closely with GTS Learning. They give me a little bit of a break on this for everybody who goes to that link for professormesser.com/netlabs, and you'll get the option for $99 to have this entire set of labs available for you for 12 months. That should give you plenty of time to work on your Network Plus certification. And like I said, try it for an hour. Maybe this is something that will work for the things that you want to do. Maybe this is something that doesn't work for you, and you just want to know before you get into it if this is something that's really for me. Try it out. They give you plenty of time to go into each one of these labs, read through them, start up some virtual machines, play around with it. Some very nice ways to work with this. And you can see all of the documentation for all of this out there on professormesser.com/netlabs. And we want to thank GTS Learning for helping to sponsor what we do here at Professor Messer. Well, we've got more questions for you. We're not done yet. I'm not, by the way, for those of you waiting to take calls, I'm not taking calls until an hour into or once we're finished with the next 5 questions anyway, because I'm going a little bit over today, but these are so good. That was not Windows 98 chat room. That was Windows Server. Let's go back to that. This is Windows Server. This is Windows 98. Where are you people? What are you doing working with this and being able to work with those? This is one of those where you have to look and see just what is going on with these pieces and being able to work with these. This is actually Windows Server, which is nice. The client, let's see what client they're running here. This looks like a Windows XP that's running on this particular client. Other labs have a Windows 7 and a Windows Vista perhaps, and other ones, especially for the A+ certification. There's a lot to work with here, but it's nice that it's got everything pre-built. There's Wireshark. Let's do a quick capture. I can't help every time I start up Wireshark. You want to learn OSI model? Grab Wireshark and just start doing a capture and start looking through the packets. It's a great way to learn and get things going. Okay, let's go to our questions. Let's go to the next question, which is, which of these would be a packet switching technology? You didn't even see the things I was doing there because I had it on the other screen. But it's not one of those. Which of these would be a packet switching technology? In this particular case, I'm asking you to pick 2 if you go to Socrative.com and go to Professor Messer as the room name. The 2 options you will choose from will be one of two of these. MPLS, ISDN, T1, 802.11n, and PSTN. Again, 2-step process. You have to go through and understand what you want to pull out and look at that. You will need to understand what a packet switching is, and at that point you have to apply it to the technologies associated with packet switching. So MPLS, ISDN, T1, 802.11n, and PSTN. I made this one a little harder because each one of these really is a legitimate network technology. This is something that would be in many different environments you go into. In fact, there's many environments that are running all of these networking technologies, but only 2 of them are packet switching. Which 2 is it? It's one of these 2. So this goes back to understanding the differences, because there's 2 different kinds of technologies. There's packet switching and there's the other one. And I'm not going to tell you what the other one is until we get to this particular one. So this is where we're going to go through and really break down what the packet switching and the differences of packet switching might be. This is also one of those times where I'm really trying to see if you know what the definitions of these things are. I'm not trying to emulate the exam. In fact, I have no idea what type of questions they're asking on the exam these days. I intentionally don't want to know because I'm building my own questions to help you understand more about the material. So some of you ask, are these like the exact exam questions? I have no idea. I already have my Network Plus certification. I'm writing these questions right out of thin air and sticking them on here because I want you to think about what is being asked of you for the exam. And some people have said, I got back from my exam, your questions were right on the money, and it's purely by coincidence, because I'm simply sitting down and writing these questions before the study group to be able to do that. So your options here, if we go back to the list of those, MPLS, ISDN, T1, 802.11n, and PSTN. What could it be? What could it be? So let's see how we did if we go to this list. And it's pretty much what I thought it might be. We've got rainbows. We've got 36% said MPLS, 17% said ISDN, 9% said T1, 6% said 802.11n, and 32% said PSTN. Well, to know which one of these things is packet switching, we need to break this down and understand the 2 different ways that you might run into these networking technologies. The first one I want to show you is something called circuit switching. Circuit switching is like an old telephone. This is something we've used for many years in technology, in IT, in telephony, in communication across wide area networks. This is one of those cases where you bring up a line and you can use and send information over that line. And you're the only one who can send information over that line. Nobody else can share this with you. You're essentially nailing up a line between 2 sections and you're sending information back and forth. If there's no information to go, let's say you're calling somebody on the phone. Hi, how are you? I'm fine. And nobody talks. that's too bad. The line is just idle. You're not even using those resources on the line. It's one of the disadvantages of circuit switching. And you can't really share this with anybody because when you bring it up, it's there. One nice thing about circuit switching, though, nobody's sharing it. You're paying a lot for it, and it's always going to be available when you want it. It's not one of these cases where somebody can overload the wireless connection. In this case, it's your single line, and nobody else can take advantage of that. So circuit switching, one of those things. So you'll see plain old telephone. If you're calling somebody on the phone, you're now setting up a circuit between those two, and there's your circuit switched. You may see this abbreviated as PSTN for the public switched telephone network. It's interesting that it's circuit switched, even though it says PSTN. It's not packet switched telephone network. It's public switched telephone network. And don't get mixed up with those abbreviations. T1, E1, T3, E3, those older technologies are circuit switch technologies, and ISDN is circuit switch technology. So knowing that the PSTN, the T1, and the ISDN are on this list, and you may already know what those two answers were from the packet switching. Remember our question asked, what is packet switching? Packet switching is the way we think about doing networking now. We bring up a link between two places. Maybe it's a trunked link that has many VPNs inside of it. And it has a lot of data that's coming from many different networks on the inside of it. If you have an idle time, somebody else can use that time on the network. We're sending little packets back and forth, and we have routers that figure out where these packets should go and switches that figure out where these packets should go. We're switching the data based on the packet, not based on the circuit or the telephone number associated with that. So if we know that, and we have that information that is out there and being used, we can think of our modern technologies are going to be packet switching. Things like MPLS, things like 802.11, things like cable modems, Ethernet networks. That's what packet switching might be. And that's why if we go back and look at things like the answer here, and we're wanting to know about packet switching, we know that MPLS is definitely a packet switch, modern technology. ISDN, that's a circuit switch technology. T1, a circuit switch technology. PSTN, a circuit switch technology, but 802.11 and MPLS are packet switch. So if you chose A and you chose D, you would be absolutely correct. Label switching is something that's done in MPLS, and the label switching is done at a higher layer than the circuit or the packet. That's something that happens at a higher OSI layer. So the MPLS is over a packet switch network, and on top of that, it's using label switching to determine where the MPLS goes. Very similar to 802.11n that is using packet switching to get to its place, and the IP address figures out where it goes from there. Think of it along those lines. That is how you can differentiate between the label switching and the packet switching. There's one of those that you can work. There was a question in the chat room also, what's a local loop? If I have that in my list of things, I may have had a local loop in my list, or you may have heard that, especially when dealing with these older technologies or even the newer technologies. A local loop is a term used by your telecommunications company that is the link that goes from the street into your building and where it terminates. That's the local loop that gets to you. And at that point, they hand it off to you, and it becomes the customer premise equipment, or the CPE, that you're plugging it into. And generally, that's where the telecommunication company draws the line. We're going to give you a local loop. Here's your local loop connection that you're paying for. You can plug that into any CPE you'd like. Go ahead, knock yourself out. But the telecommunications company generally not interested in keeping track of your personal CPE information. So that's why you are up to you to troubleshoot from there. One of the things the telecommunications company can do, and where that looping comes from, is they can loop that back to the main office there by sending a command off to the telecommunications equipment that's on site. It helps them troubleshoot these lines in the local loop piece. Well, we've got more questions for you. For instance, which of these would be most commonly seen in the IDF? Which one of these would be most commonly seen in the IDF? You can answer this question on Socrative.com. Go to the Professor Messer room. I think we've pretty much figured that out by now. So which of these would be commonly seen? Is it WAN termination points? Is it email servers? Is it workgroup switches? Is it core routers? Is it a storage area network? So now you have to know what an IDF is. And then once you figure that out, you have to figure out what goes in an IDF. So again, two-step questions. I'm trying to get you thinking about these things. This is the one where you really have to go through each one of these and figure out. It also helps if you know if it's not in the IDF, where is it? In fact, it's those names that can kind of give you a hint to this particular question and what's there. So is the WAN termination point? Is it an email server? Is it a workgroup switch? Is it a core router? Or is it a storage area network? What is it? What is it? What is it? Who knows? I'll give you some time to mull that one over. This will be important. The Network Plus exam expects you to know what an IDF is and expects you to know what goes into an IDF when you're working with one. That is an abbreviation that does stand for something. Kind of an old name that we use. Yes, some of these questions are a little tricky. I'm trying to get you thinking about these two-step questions with some of these. And it's not things we generally go through. You don't think about these terms unless you're using them. But there are places where you would go and, hey, you need to go down to the IDF because I need you to do this. Or you need to go to the IDF in this building because I need this particular thing done. I guess that's the only hint I can really give you from an IDF perspective. Let's see how we're doing with this. We've got a number of people who have answered this one. And again, we got rainbows. We got a little bit of everything here, almost a little bit of everything. So what's in an IDF? Is it a WAN termination point? 28% of you said that. 0% said email servers. No email fans in the room at all? Nothing. 50%, the majority, or what was the majority, workgroup switches. Core routers would be 11%, 10% of you, and storage area network, 7% of you said that. So what is it? What is the answer in this particular case? Well, I'm glad you asked because I have some answers for you. First, before we talk about an IDF, let's talk about the IDF's big brother, which is the MDF. MDF stands for the main distribution frame. There's usually one MDF, just like the name implies, a main distribution frame. Such an old terminology we're using for this. It's your data center. It's the main room where everything comes into. I guess technically it could be a room separate from the data center, certainly, but usually the MDF is a central point of the network. You usually see a big bunch of wires on the wall with punch downs like the one that you see here. All of the links from all of the other locations. Maybe you have 10 buildings on your campus. All 10 of those buildings come back and they terminate here in the MDF. The MDF is generally where your data center is. Usually your central servers are in the MDF. It is the main distribution frame. If everybody in all 10 of those buildings need to access a resource, we're going to put the resource in a central place, and the MDF is a good central place for that. An IDF is the intermediate distribution frame. This is one that is anything other than an MDF. It's the next link down the line. So we have those 10 buildings in our campus. Each one of those 10 buildings would have one or sometimes more IDF. Especially if it's a big building, you might have an IDF on every floor of that building. But it's the intermediate point. It's the midpoint between the MDF and the end user. So we usually will extend out the links from the MDF out to the IDF. So there'll be a big pipe going out. I say big pipe, it may be a physical pipe with some fiber inside of it, but usually a fiber connection, a lot of bandwidth is what I mean when I say a big pipe. A lot of bandwidth to the IDF, maybe just a single fiber link between the MDF and the IDF. And from there, we've got a bunch of workgroup switches. We've got devices that will be important to use at a local level for everybody who's connecting in from that floor into the IDF. So you will probably see local things in the IDF to work with. So if we go through our list again, we've got WAN termination points. Usually the WAN is terminated in the data center. That's where your routers are. That's where your core switches are. That's generally where you're also bringing in all of the telecommunications lines and plugging them into your CPE. Grab your local loops, plug them into your CPE. You do that and the MDF. So that would not be the correct answer. Sorry, 24% of you. Email servers, again, a central resource. That's also in the MDF. We're, of course, looking for IDF, which would be commonly seen in the IDF. Core routers are certainly things that are in the MDF. They're a main central resource. They would not be in the IDF. And a storage area network certainly is something that needs to be centrally accessed by all 10 of those buildings, not just one of them. So it would be the storage area network. Not correct. Your correct answer, the 54% of you said workgroup switch. You were absolutely right. That is the correct answer for this particular question. So, got some folks really doing well in the chat room. Let's do another one. Let's do a question. I've got a question for you. In which of these cases would you use a TDR? Again, I'm giving you these questions that are wrapped in an enigma. They have a separate step that you have to go through. You have to know what a TDR is. And then you have to be able to know, do I use a TDR to connect an Ethernet cable to a patch panel? Do I use it to determine the cable length of a cable? Do I use this to run diagnostics on a network interface? Or do I use it to terminate a WAN connection? In which of these cases would I use a TDR? TDR. So it's one of those cases where you do have to know what a TDR is. I'm really trying to mix up some of these questions from a lot of different places around the Network Plus exam. You know, one of the things I get a lot is in these questions I get every month is very common question. I need more subnetting. I need more subnetting. I need to know more about subnetting. I need to know a lot more about subnetting. And subnetting is on the exam. It's a very little piece of the exam for Network Plus. There are other industry exams that go much deeper into subnetting. And certainly subnetting is an important thing to know. You should sit down and do subnetting. I have plenty of videos on binary math and understanding the basics of subnetting for the Network Plus exam. But as we're going through here, you can kind of see none of this is dealing with subnetting. We've not talked one thing about subnetting, and we've talked about so many different topics. And this is another example of hitting a topic that is, again, very different. I try to mix it up in these study groups and give you something different. Unfortunately, people are asking for very different things on here as well. In which one of these cases would you use a TDR? TDR. So let's give you a chance to answer that. I think we've got a few people that have put these in here. And again, I love it when I get a little bit of a variety in answers. And don't be too concerned if you're answering these questions and you didn't get that one right. That is the best thing when you don't get a question right, because then you learn from what you just missed on there, and it tends to stick a little better. I sometimes like it when I break something. I don't at the moment, but once I fixed it, I've learned something once it's broken and gone through the mix. And this particular case, we have this case as well where 7% said this is what you use. A TDR is what you use to connect an Ethernet cable to a patch panel. 50% of you said determine cable length. 36% of you said run diagnostics on a network interface. And 9% said terminate a WAN connection. You know, one of the things about the Network Plus exam is you have to choose the best answer. And I don't know if I put it that way. I really said, in which of these cases would you use a TDR? If I was really thinking about this one, I would say, in which of these cases would you be most likely to use a TDR? Because there's a little bit of vagueness here. Not really. If we're talking TDR, we're talking, you should know what a TDR really is and be able to work with those pieces. In this case, let's talk about a TDR and what that happens to be. TDR stands for time domain reflectometer. This is also an optical, if you're using fiber, it's an optical time domain reflectometer. It is something that's got a big long name to it, but it really is a device you plug into a cable or fiber, and you use this to be able to gather information about that piece of cable or that piece of fiber. It's very common to use this to estimate cable lengths because it sends a signal down the cable and it receives a reflection back, and that reflection gives it an idea of how far away that particular end of the cable is, or a kink in the cable, or a problem with the cable, and you're able to see exactly where that problem happens to be. You can see splice locations, impedance information, signal losses. It's a physical level piece of technology. So if you're one of those people that answered in here, B, determine cable length, you're absolutely correct. We're not using this to connect an Ethernet cable to a patch panel. That's generally a punch down tool. We don't run diagnostics on a network interface with a TDR. Generally, you're plugging in a loopback connection for that. And these have limited functionalities. A TDR traditionally doesn't do anything with network interfaces. A TDR is all about the cable. The cable. no trouble. There's terminate a WAN connection, D. Again, you're terminating a connection using a punch down cable, something else. It's not one of those cases where you really would fit any one of those in. It's going to be something dealing with wire. It's going to be something dealing with fiber. It's going to be determining a cable length. And of course, any of these other things too. TDR is a great tool. It's expensive. And again, the chat room, as I look down, they go, yeah, they're expensive too. They are. They're pricey little pieces of equipment. But if you're doing cabling, you're doing a lot of cabling, you're putting in a lot of equipment, you need a TDR. They're really great to be able to have that there. So it's it is, yes, a reflection at a particular time gives you the distance. And of course, you have to tell the TDR, I'm using this kind of cable so that it understands what the propagation delay is for information, electrical signals being sent over that copper. And that's a piece of information you can get from the cable manufacturer. And so that it's able to calculate when it receives the reflection, how long did that take, considering how long the delay is to be able to send information back. Very, very amazing piece of technology to be able to use that. Comes in handy. I like using a TDR. It can save you if you're trying to figure out where a problem is with a cable. It's a great tool to have there. Let's go to another question. Next question. In which of these cases would you use dig? I'm not saying in which of these cases would you dig something, although that's cool. You can dig it. I'm cool with that. I'm really asking about a specific utility called dig. So what is this when I would use dig? How would I use dig? Again, a two-step process to be able to do this. I have to know what dig is so that I can answer the question, would I use dig to query a DNS server? Would I use dig to display the local IP configuration? Would I use dig to determine the route to a remote IP address? Or would I use dig to store logs from a router? Each one of these things are useful to be able to do that. I think there's all kinds of nice things you can do with dig, but only one of these answers is going to be the correct answer. Can you dig it? I can dig it. So that's where we go with this. In which of these cases would you use the dig? How would I dig? In which cases would I use the dig? This is also one of those things on the Network Plus certification. In fact, you probably not only need to know what dig does, you need to know how to use dig. And in fact, in my videos, I take you through me using dig. I step through dig and what I'm doing with dig, and you watch me digging it. We'll do some of that here as soon as we get an answer, because some of you are sending in your answers by going to Socrative.com, and you are answering this particular question of which of these cases would you use dig? Query a DNS server, display the local IP configuration, determine the route to a remote IP address, or store logs from a router. And didn't really fool anybody on this one. 80%, huge number so far, saying query a DNS server. 60% said display a local IP configuration. I got a few bytes on determine the route to a remote IP address. And D is store logs from a router. Well, dig is one of those things that we'll show you what this does. We will dig right now. We're going to dig down into this. So here's my terminal session. I'm going to dig www.google.com. I've just done a DNS query to google.com. In fact, it tells me I'm running dig. I'm doing this to google.com. You're getting, you got an answer, and it's got no error in the answer. It was a query that you made, and you got 6 answers actually for google.com. And you can see Google's got a lot of machines. They just don't have one big server that has everything on it. They happen to have multiple IP addresses. I had no idea. And it told me that, yeah, there's a lot of Googles out there you can go to, 74, 125, 196.99. This query time took 60 milliseconds on server 8.8.4.4, which happens to be Google's DNS server, because that's what my machine is set up for Google's DNS on Saturday, August 30th at 1:07 already. Let's do another one. I'm going to dig ProfessorMesser.com. Let's see what kind of response we get. And 2 IP addresses came back for that one. Indeed, I do have redundancy. And the IP addresses you get for ProfessorMesser.com will be different depending on where you are in the world, because I have redundancies upon redundancies upon redundancies set up. And so depending on where you happen to be geographically, you may get different IP addresses, but this is what I get, 162.159. So this is when you would use dig. You would use it to query a DNS server if you were one of those 70 people, or 70% rather, that did that. Now, can you remember what other utility might be used to query a DNS server? What possibly could that be? it would be NSLookup. NSLookup is one great way to look this up. In fact, if you're in Windows, that is probably the tool that you will use, because Dig is something that is not included with Windows. You would have to go and download the Windows Dig utility from, I believe it's the Berkeley Internet Name Services distribution, the Bind distribution. So that's one of those things. NSLookup has indeed officially been deprecated. Everybody says use Dig instead. So we will probably see in many different distributions, Dig is probably going to be the default thing. Dig's so much better than NSLookup anyway. It works great. You'll love it. All right, let's ask another question. Got more questions. We got stuff to do. Let's step through. That was an easy one for you. So let's see if I can throw in a different one. Which of these would be an example of an evil twin attack? The evil twin. So I have some options for you. Go to the Professor Messer room on Socrative.com. The options are A, configuring a fake wireless access point. B is overwhelming the session table of a server. C is performing an ARP poisoning. And D is accessing a database using unfiltered application input. All of these sound like something that I don't want. But only one of them is an evil twin attack. Is it configuring a fake wireless access point, overwhelming the session table of a server, performing an ARP poisoning, or accessing database information using unfiltered application input? This is one of the parts I mentioned earlier that the Network Plus certification added a lot of security things to it. This is a very good example of some of the security things that you need to know about. So this is where evil twin attacks is an important thing. In fact, you should go through this list if you're a pro. You'll go through this list and you'll know exactly which one of these things are associated with what attack type. So those of you that think you know the answer, go through the other answers and tell me what the attack type is for each one of those. And we're going to go through each one when we're done to be able to do that. Very, very useful to have that there. The evil twin problem is one that you do want to be careful about. So each one of these things is a problem. Without giving you too many specifics with that one, you'll be able to know how we did there. So let's see if we fooled anybody with this one. Darn it, I really didn't. Like 87% of you said configuring a fake wireless access point. I think we can call it at this point that you would be absolutely correct. Overwhelming the session table of a server. What would that be? What kind of attack is that? Session table of a server, overwhelming it, just hitting it over and over and over and filling up the session table so that nobody can access it. It's almost like you're denying the service. So that is a denial of service, overwhelming the session table of a server. Performing ARP poisoning. I would generally perform an ARP poison on a device if I was planning to do a man in the middle. So that is the type of attack that would be associated with that. And does anybody know what accessing the database information using unfiltered application input? It's kind of vague. It could be a couple of different kinds of attacks, but generally we think of something like a database injection is a very good way to access database information using unfiltered application input. Very, very useful to know what some of those things are. Evil twins, they can be bad. That's why if you ever go to a trade show where somebody is doing anything related to security, you want to be very careful, because you run into these situations where somebody just grabs a wireless access point or even a specialized device, sets up their own wireless network, makes it look like the wireless network for the show, and now everybody's connecting to it. And if you're now checking mail in the clear, you're telnetting to a device in the clear, you're not using a VPN, you're not connecting to a device over an encrypted channel, all of that information is going to be in the clear. So that is how you have problems with wireless access points and dealing with things like an evil twin attack. Boy, a lot of concerns we have to think about when we step out of the network that we used to know. You really run into problems when you start working with those things, and the wireless evil twin is certainly one of those things we need to watch out for. Well, we've come to the end of our questions in today's study group. For those of you on Socrative, I'm going to pop up a question. You'll see it now about what topic would you like to cover on the next Security Plus or Network Plus study group. Boy, was that Freudian? I said Security Plus study group. But I do have some other things. People were asking some questions while you're filling that out. How long should a person study before attempting the test? And I always say, and I've said in this study group already, go download the objectives. There are pages and pages and pages and pages of exactly what you need to know for the exam. So if you're the person in the room who raises the hand and goes, will this be on the test? You don't even have to ask. Go to professormesser.com/objectives or simply type into the Google CompTIA Network Plus exam objectives. It will take you to this and you will be able to see the objective list. It is enormous and it tells you everything. Sadly, I have people that will come to the website and they go, I just failed my Network Plus exam. And I said, well, when you went through the exam objectives before you took the exam, was there any particular area that you didn't feel good about? And they go, what exam objectives? What are you talking about? These exam objectives. It tells you everything. Make sure you download those. There's another question we got in which says, how can I keep CompTIA certifications from expiring once they've been earned? And again, CompTIA has a renewal process. Your certification is good for 3 years. There's a number of different ways that you can renew it. Probably the easiest way is to take a higher level certification sometime in the next 3 years. You take your Security Plus, it's going to renew your Network Plus, that type of thing. But there are also things you can do like watching a study group, writing a blog post. If you really want to keep your exam, make sure you go to the CompTIA.org website and look at their certification renewal process. That's what you want to be able to work with. So some of you have answered and shown me some of the answers. I'm seeing some of the answers here that you want to do for the next Network Plus. I'm seeing the switches, wireless, virtualization, and cloud, which would be an awesome thing to go through. A lot dealing with router configurations, managed versus unmanaged gear, those types of things to be able to do that. So there's a lot that we could go through. And make sure if you have any questions, you don't have to, after this study group, live study group's over, people can't go in and answer the questions. It's already closed up. I've already taken down the Socrative link, but you can always go to the Professor Messer website and go to Contact Us and tell me exactly what you're interested in knowing for the next study group. I'll remind you that my study guide's available for $10. If you're ready to take your exam, you need a quick sheet that goes through everything. You can go to professormesser.com/netsg. Of course, if you don't have the money for a study guide, you can't really buy the videos. You like that they're free, and I like that you watch them, and you still would like to contribute in some way, I can't tell you how important it is to go out to YouTube and subscribe to Professor Messer. If you go to professormesser.com/YouTube and just subscribe to our page. I don't send out massive amounts of updates. And of course, you can tell YouTube if you ever want to receive an update from me, but it goes a long way with the nice folks at Google when I have a lot of subscribers. That's why we always say, please subscribe. Don't forget, it really is very important. And if there are other people, you love their videos, subscribe to their channel. They will thank you immensely for doing exactly that. You can, of course, follow me on Twitter, professormesser.com/Twitter, Google Plus at professormesser.com/Google Plus, the Facebook at professormesser.com/Facebook. Of course, you're going to be able to look at the GTS learning, and don't forget to take advantage of that free 1 hour of lab time at professormesser.com/netlabs. And of course, thanks for another great Network Plus study group. Although our questions are over, we sort of shut down the study group officially, the show, but we do an after show afterwards. You're welcome to join us and go through that piece. Remember, everyone, decisions are made by those that show up. Thanks for showing up for this, and we'll see you next time on the Network Plus study group.